All right, we're going to be working on homework for Module 3, which is Chapter 5, talking about the normal distribution. You watched a couple of videos. I'm going to go through this very quickly. The first question is, a normal curve is a theoretical idea or model, can be used to describe the statistics, and is used in statistical decision making. Those are all true. A normal curve or distribution was made up, and I think I've already gone through one of these in the videos. It was made up of just asking a bunch of questions and forming frequency diagrams. And when you go to infinity with the number of people you actually interview, you get there. So number 2, a probability distribution. A probability distribution, same thing as a normal distribution, it has a mean and a standard deviation. So the answer here is going to be B. All right, number 3. 3, a probability distribution is essentially a frequency distribution of percentages for, the answer is going to be D, an infinite number of cases. Right? Probability distribution is a frequency distribution. Remember, frequency distribution was where you ask the number of times, all right, something has happened, or interview people, and eventually you find out that if you ask n to 1 million, n to 5 million, n to 6 million, that is going to eventually start to look like this. My camera's going to go in and out because it's a photo camera. Sorry about that, guys. I'll try not to move too much. Remember, question number 4. Empirical probability distributions are those dependent on observation to determine or estimate their values. Empirical evidence, not real evidence, but you're just doing observations. If I said I know something to be empirically true, it's because I personally observed it. That's it, right? Question number 5. If 68% of IQ scores are between 85 and 115, what is the probability? There is a very strong correlation. A lot of you are getting probability and percentages confused. If something is 68%, to convert it to probability, you are going to get rid of the percent sign, and you're going to move the decimal over 2 places. So we're going to go 1, 2. It's going to be 0.68, right? That makes it a probability. Probability, like it was in the video, must be between 0 and the number 1. And so probability is usually denoted with the letter P. And so if the probability that it's going to rain today is 30%, then the probability that it's not going to rain today is going to be 1 minus 0.3, which is 0.7. And we say the probability is something happening, so I would say occur, right? Something occur. And then 1 minus P is it for it to not occur or not happen. And P plus 1 minus P is an identity, must be equal to the number 1. So if the probability that you're going to make 100 on the exam is 1, then there's a 0% probability that you are going to fail the exam. All right? Question number 6 is a probability question. If the probability of giving birth to a boy is 0.5, and a woman can only give birth to a single boy and girl, then the probability of giving birth to a girl is, all right, so we know that the probability of a boy is equal to 0.5, 1. We know that the probability of your child's gender has to equal 1, so you can just simply take 1 minus 0.5, 1, which is going to be 0.49. When you look through those, that would be A and B and C. 0.49 and C. All right, number 7, in the symmetrical distribution, what percent of the scores are above the mean? This is the symmetrical distribution. Therefore, we know if we split it in half, we know the whole area under here is 100. If we split it in half, this has to be 50%, and this has to be 50%. And we know even further that 1 standard deviation, 2 standard deviations, 3 standard deviations. All right, that's number 7. Question number 8, let's see. Probability is probably best defined as the number of times the outcome or event can occur divided by the number of times that the outcome or event can occur. The number of times the outcome or event can occur over the total number of times that an outcome or event can occur. So if we could just kind of jump to question number 12, right? The probability of a student correctly guessing the answer to the question. So if it is the number of times an outcome or event can occur, well, what do I want to occur? I want them to correctly guess. So if there are 4 answer choices, of those 4, only one of them can actually be correct. So the event that I want to occur is 1 time over how many possible choices could they pick? 4. So the probability of guessing correctly on a test, a question, is going to be 25% or 0.25. 25%. I know a lot of you want to say it's 50%, either you get it right or wrong, but that's not the choice, because that would happen if you were doing a coin, because a coin has two sides. There's two total possible outcomes with a coin. With a multiple choice question, there could be however many choices there are selecting, but there's only one correct answer. All right, so it is 0.25. If there had been 3 questions that I could choose from, A, B, and C, then there's only one correct one over the total number, which would be 3, which would be 33% and a third percent. All right, so that was number 12. Let's go back to number 9. Roughly blank percent of the total area under the normal curve rests between the mean and 1 standard deviation above. That's just straight out the book. There's a picture, it shows you that this is exactly 34%. Making this minus 1 standard deviation plus 1 standard deviation equal to 68%, right? Those are straight out of the book. I'm going to move away from the thing so you can see it better. Question number 10, roughly blank percent of the total area under the normal curve between 2 standard deviations. Right out the book, it tells you at 2 standard deviations, we're looking at 95%. Now that means is if I were going to guess a number, I'm 95% accurate. It's going to fall between here and here. But it could actually, it doesn't have to, I'm just guessing. And my probability is that it's going to fall within here, but it really could fall outside of the curve. That's very rare and unlikely. Matter of fact, it's only 5% likely, right, that it would fall outside of 2 standard deviations. A normal curve is just an idea. There is no such thing in the real world as an idea. We call that a theoretical model. All right, question number 12. Let's see if I have 12. We did already. All right, question 13, the probability of flipping 2 heads in 2 flips of the same coin. I posted a video of that. I believe that I got off Khan Academy. I'll put that up here with this as well. But if I'm trying to get a coin toss, all right, it could either be heads or it could be tails, right? The probability that it's going to be heads is going to be 0.5, and the probability it's going to be tails is going to be 0.5. So I'm looking for 2 heads in a row. So here, at my second toss, it could either be heads or tails. Each probability is still 0.5, 0.5, right? And so for it to get 2 heads in a row, you just multiply the probabilities by each other. 0.5 times 0.5 is going to give me 0.25, all right? That is number 13, all right? Number 14, the probability of rolling a 4 on 1 toss of a 6-sided die, right? So the probability of rolling a 4, how many sides on a 6-sided die have the number 4? Going to be 1. And over how many possible sides are there? They're going to be 6. So 1 divided by 6 is equal to 0.167. That's how you got that answer, 1.67, right? Question number 15. Average price of a new car is $18,000 and standard deviation is 1,500. Calculate the z-score. Right? To calculate z-score, you've got a formula here, right? The z is always going to be equal to x minus the mean over the standard deviation. Make sure you put them in the correct answer. The mean is going to be given and the standard deviation is going to be given. So here I'm going to have x 16,000 minus 18,000 divided by 1,500, and that's going to give me a negative 1.33. This is my z-score. All right, if I want to know what probability is above 16,000, I would have to go and figure out what is my probability based on my z-score. Number 16, same way. The average price of a new car is 18. Standard deviation is 1,500. What is the individual score, the z-score for the 19,000? Instead of having 16,000, I'm now going to have 19,000. 19,000. And so now my new z-score is just going to be, and it makes sense, 0.67, right? And think about this. Does your answer make sense? Is this above the mean? Yes, this is a positive number, 0.67. Therefore, I know I'm in the right direction. All right, number 17, average price of a new car is 18. So obviously by now you should know I'm going to ask you this question on the exam. 18,000, standard deviation is 15. Calculate. I know I'm looking for 21,000 minus 18,000 divided by 1,500. That's going to give me a z-score equal to 2. All right, a z-score equal to 2. Question number 18. Which of the following is not true of the normal curve? All right, so the normal curve, which we already talked about and I've seen in the videos, normal curve is definitely symmetrical, so it just means you could fold it on itself, right? This is question number 18. The area underneath it is 100%, and a normal curve has a mean, mode, median, and mean. They're all identical, all right? So question number 18, it is skewed. It is not skewed, all right? This is an example of a skewed curve. We would lean to the right, lean to the left, all right? Which of the following is true of probability? The answer is going to be a probability varies between 0 and 1. If you give me, on the exam, if you have an answer for what is probability and you give me a number greater than 1, then you're wrong. If you're going to say 2.4, you're probably looking for 0.24. Right? On a normal curve, the mean is 7.2, standard deviation is 1.5. What is the z-score for 9? I'm asking you to plug those in. So you're going to have 9 minus 7.2 divided by 1.5 is going to be equal to 1.2. Right? Using the info from the above problem, what is the probability associated with 9? Right? This is where you need to take this 1.2 and you need to go to the back of the book, and I'm going to show you that today. You need to go to Appendix C in the back of the book. And I'm just going to push my book up, and hopefully you'll be able to see it. And what I'm looking for there is I'm looking for 1.2. So I go to page 360 in my book, and I'm looking for 1.2. Everybody, well, what's it, everybody, as if I'm talking to somebody. All right, and I'm going to find when you come across 1.2, get a really tight shot of that, all right? You can see that 1.2 corresponds with 38.3, the area between the mean and z. So what that looks like, that 1.2 corresponds with saying this would be the 1.2 z-score, and it's going, the area from here to here is 38.30. 38.30. That would be this area. So if I wanted to calculate everything above 9, I could take 0.5 minus 38.3, or like you did with your height, if I wanted to take everything below 9, I could take 38.3 plus this side, which is 0.5, so I would have 88.3. That's just extra. Number 23, the mean of a test is 7.2, and standard deviation is 1.5. What is the probability of scoring an 8? All right? So here, I've got the same number, 7.2, 1.5. I'm asking you about an 8. I then have to calculate what my z-score is. So I have 8 minus 7.2. Eight minus 7.2 divided by 1.5 is going to give me 8 minus 7. Hold on, my calculator. 8 minus 7.2 divided by 1.5 is equal to 3.2. All right, I've got something in my calculator. 8 minus 7.2 equals 0.8 divided by 1.5. All right, it's going to give me 0.533. So my z is going to be 0.533. So now I need to go into the book and look for 0.53. When I go back to page 361 and go down the list for 0.53, I find out that it corresponds with 0.53, 20.19. All right, 20.19. So if it's asking me what is the probability of scoring that, it's going to be 20.19. All right. Number 24, IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. based on the normal distribution, what is the percent of IQ scores that fall between 100 and 120? All right, so when I am looking for, in this example, I have my normal distribution. I know that the mean here is going to be equal to 100. I know that my standard deviation here is equal to 15, and it's asking me how many scores fall between this 100 and 120. And so what I need to do to be able to compare these two, once this kind of gets into focus, let me move out of the way, right? What I need to be able to compare these two, okay, is I need to convert the 120 into a z-score, all right? By converting the 120 into a z-score, I'll be able to figure out that area. So if I take 120, and I hate to come back on the screen, 120 minus 100 divided by 15 is going to give me the 10 divided by 15. Divided by 15 gives me the 0.6667. You're halfway there. All right, 0.6, so this gives me 0.6667. I need to go into the book and find out what is 0.67. When I go into the book, and I want to be able to give that to you there. Looking in the back of the book, I find out that the area between the mean and the z is 24.86. 24.86. Oh, you know what? I messed up. Here, I was actually saying 10. I should have said 20 divided by 15. So, sorry about that. And I'm not going to correct it because I'm just throwing this video up there today. 20 divided by 20, my calculator, divided by 15 is going to be 1.33. That makes better sense. 1.33. When I go to the book to find 1.33, 1.33 in the book on page 362 corresponds with 40.82. 40.82. So the answer there is going to, and so what I'm looking for is giving me this area right here. The probability of this is 0.482, but the probability is going to, is going to be 40.82%, right? Based on normal distribution. All right, that's number 24. And the last question, number 25. Using the data of 100 and standard deviation 15, the probability of selecting a person at random of an IQ between 88 and 100. All right, so now I'm asking you, tell me what's the probability of selecting someone between 88 and 100. So we're going to go the other side this time. I am now looking for 88. Get rid of my 120 there, which means I'm going to have to calculate the z-score for 88. The z-score for 100 is just 0, right? 100 minus 100 divided by standard deviation. 100 minus 100 is equal to 0. So here I'm going to have my x, my z is equal to 88 minus 100 divided by the standard deviation, which it said was 15 before. Let me get out of the way so you can see that. 88 minus 100 divided by 15 is going to give me 0.8 and a negative 0.8. So the z-score here is equal to negative 0.8. All right? So that means I go to the book and I look in here for 0.8 and I find that that corresponds with 28.81. 28.81. All right, 28.81. What if the problem, this is extra, had asked me, what's the probability of finding someone between 88 and 120? Right? Then I would have to know what was the 120. I had that from the problem that we just did. I knew that that area is equal to 40.82, so I could add these two together. 40.82 29.82 plus 28.81 is going to tell me 69.63% of the population is going to fall between having an IQ of 88 and an IQ of 120. I could have also asked you, what's the probability of finding somebody with an IQ greater than 120, right? If I know that the area between 100 and 120 is 40.82, and I know this whole side is equal to 50%, I could have just taken 50 minus 40.82, and that tells me 18% of the population is above 120, right? If you have any questions about any of them, please send me an email. But other than that, I think you guys should do great. You did great on the homework. Thank you.